Welcome to Study Loop.
Okay, so this Milky Way problem is based on orbital motion and really has to do with dynamics, with classical mechanics. And so, for and in order to determine mass of the Milky Way from stars, from the motion of stars. So, part A, we're going to start with this equation. The escape velocity is equal to square root of 2 times the gravitational constant times mass within radius r naught over r naught. So to find the mass, that is equal to escape velocity squared times distance r naught over 2 times g. And from page 908 of the book, the high velocity stars from Oort have a velocity of 300 kilometers per second, and we want to convert that to parsecs, to kilometers per second. Excuse me. And so you're going to multiply that by 10 to the 5 to get centimeters per second times the distance r naught, that's 8,000 parsecs. Multiply that by 3 times 10 to the 18 to get centimeters. Divided by, whoops, forgot the square here. That's divided by the gravitational constant in CGS units. Okay, so this will give you a value, a mass within R naught of 1.6 times 10 to the 44 grams. And you multiply that, you divide that by about 2 times 10 to the 33, and you get a mass and solar masses of 8.1 times 10 to the 10 solar masses as the mass within that radius. And from example 25, or example 3.1, the mass is given as 8.8 times 10 to the 10 solar masses, which is very close to our estimate. And for part B, what's happening is we're taking extremely high velocity stars, so these have escape velocity of around 500 kilometers per second. And so replace that in the equation above, and this will give you mass within R naught of 4.5 times 10 to the 44 grams, which is about 2.25 times 10 to the 11 solar masses. A little bit more than this estimate. And finally, for a little bit, and so just to finish this off, this extra mass could be and most likely is due to the dark matter halo of the Milky Way. And finally, for part C, the problem with using motion of stars in the neighborhood of the solar system to determine the true mass of the Milky Way galaxy is that a lot, and I mean a lot, of mass is at radii greater than r naught, so very far away from the Milky Way's, from the solar neighborhood, and so it does appear that this is spherically symmetrically distributed, and this mass beyond r naught is does not really affect the motion of stars in our solar neighborhood. So, so, estimating the mass of the galaxy from stars near our neighborhood does not work very well, not give us a very accurate answer.